Hi, Timothy Unkert here. In this video, I'm going to look at some exponential word problems. So let's take a look at problem one. Problem one reads, a population of hairy apes in the Sierra Nevada mountains is 1,000 in the year 2000. Over the next 10 years, the population increases by 6% per year. What is the population of hairy apes in the Sierra Nevada mountains in 2010? Okay, so let's write our function for our population, and let's try and do a straight line. Let's write that as population as a function of time. Okay, so that's going to be the base amount, which is 1,000. Or, sorry, this is going to be the initial population, I should say, times the base amount, which is going to be, well, how do we represent 6% increase? So that's 6% over just, if the population were just staying at 100% of what it was, that would be times 1. But if we want to increase by 6%, that's 0.06 in addition to the 1. So we're going to multiply by 1.06. And if we do time in years, we'll raise that to the t power, because they increase by 6% per year. So the population after 10 years, from 2000 to 2010, should equal 1,000 times 1.06 to the 10th power. So I'm going to switch over here to Desmos and enter that in. So we'll do 1,000 times 1.06, and we'll raise that to the 10th power. And we get a population of 1,790.84. We're just going to use this as an estimate and say it's 1,791. So we'll do it to the nearest hairy ape. So we'll do 1,791. You know what, we can do it's approximately. So I'll do that like this. So approximately 1,791 hairy apes. Okay. Next one, a radioactive element has a half-life of 50 years. There is currently 1,000 grams of a sample of the element. How many grams will there be in that sample 1,000 years from now? Okay. So to set this up, so we'll say the amount as a function of time. This is a little bit better here. That's going to equal the initial amount of the sample, so 1,000 grams, and every 50 years it gets half of that, so we're going to multiply this times 0.50, and if time is in years, since this happens every 50 years, we'll take the time in years and we'll divide it by, let me write that a little bit better. That t is kind of not so great. So we'll take the time in years and we'll divide that by 50, because the half-life is 50. Okay, so the amount in 1,000 years is going to equal the initial amount, 1,000, times 0.50 raised to 1,000. Oops. Let me move this over a little bit. Raised to 1,000 divided by 50. Okay, so let's do that in Desmos. Okay, so we have 1,000 times 0.50, and then we're going to raise that to 1,000 divided by 50. Okay, and in 1,000 years, we're only getting 9/10,000ths of a gram. So our amount is going to be approximately, let's make sure we did all that right. Yep. 9/10,000ths of a gram. Of whatever this element is left. Okay. So, and that's grams here. You should always label these. I'm having trouble writing with the mouse, which is why I didn't write my hairy apes over here, but I should. Always the label. Okay, let's try a couple more. Let's go on down here. Let's look at problem 3. So a bacteria in a petri dish has 200 bacteria cells now. The bacteria triple every hour. How many bacteria cells will be in the petri dish in 1 day's time? So this is the population as a function of time equals the initial amount, 200. They are tripling every hour. We'll do times 3 to the t power, if t is in hours. And so 1 day is 24 hours. So population in 24 hours is going to be 200 times 3 to the 24th power. Okay, so let's do that one. So 200 times 3 to the 24th power, and we have 5.65, we'll say, times 10 to the 13th power. So we have a ton of bacteria. So approximately, let's see again, it's 5.65, roughly. Times 10 to the 13th power. It's a very large number of bacteria. Okay. All right, so the population of certain species of tiger in Asia is declining by 25% per decade. There are currently only 10 tigers of this species in the wild. How many will there be in 1 century from now? So we're looking at, again, population as a function of time. It's going to equal the initial amount, 600, times, declining by 25% is 1 minus 0.25, so it's going to be multiplied by 0.75. And we'll have t in years, and we're going to divide that by 10. It's every 10 years that they decline 25%. So our population after 100 years is going to be 600 times 0.75 raised to the 100 divided by 10 power, or just the 10th power. So let's put that into Desmos. So we're going to do 600 times 0.75 raised to the 100 divided by 10. So we have 33.78. So approximately after a century, there'll be 34, right? 33.78. So there'll be approximately 34 tigers left. Well, hopefully you found this video helpful. If you did, please give it a like and consider subscribing to the channel. Thanks for watching. Hope to see you in the next one.